everyone. I am Shivani Shri. I am going to speak about the topic municipal water treatment in river or sea water. Water treatment is any process that improves the quality of water to make it appropriate for a specific end use. The end use may be drinking, industrial water supply, irrigation, river flow maintenance, water recreation, or many other uses, including being safely returned to the environment. Water treatment removes contaminants and undesirable components or reduces their concentration so that the water becomes fit for its desired end use. This treatment is crucial to human health and allows humans to benefit from both drinking and irrigation use. Domestic and industrial water supply is the two types of wastewater. Wastewater contains sewage, bacteria, viruses, hazardous and non-toxic organisms, sanitary outputs, rubbish, detergents and other solid and liquid discharges from non-manufacturing processes. Conventional surface water treatment: collection, screening and straining, chemical addition, coagulation and flocculation, sedimentation and clarification, filtration, disinfection, storage, distribution. And this is the diagrammatical explanation. Screening and straining. If you think about surface water sources, that is lakes, rivers and reservoirs, you realize they contain varying amounts of suspended dissolved materials. This material may include turbidity, color and taste, odor, microorganisms, fish, plants, trees, trash, etc. The material may be organic or inorganic, suspended or dissolved, inert or biological active, and varying in size from colloidal to a tree trunk. Some of these larger items can impede equipment in the treatment process, such as a tree limb getting stuck in a water pump impeller. So the first process in conventional water treatment is the screen or strain out the larger items. This is often accomplished using a large metal screen, often called a bar screen, which is placed in front of the water source intake. Large items are trapped on the screen as the water passes through it. These screens must routinely be raked or cleaned up. Chemical addition: once the pre-screened source water is received into the treatment plant, chemicals are added to help make the suspended particles that are floating in the water clump together to form heavier and larger gelatinous particle, often called floc. Coagulation and flocculation: a rapid mix unit is usually used where the coagulant is added to the water to provide a very quick and thorough mixing. The water mixing is often then slowed to allow the water to come in contact with the forming floc and allow it to increase in size. The continued mixing must be gentle to allow the floc to grow and gain weight, but fast enough to keep it in suspension until you are ready for it to settle in the clarifier. The process of adding a chemical to cause the suspended material to clump into larger particles is called flocculation or coagulance. The treatment unit where coagulation and flocculation is formed is called flocculator. Sedimentation and clarification: once the flocculation process is complete, the water then passes over the wire in the flocculator and travels to the center of the clarifier or sedimentation basin. Here the water makes its way from the center of the clarifier to the tooth wire at the perimeter of the unit. As the water makes its way towards the wire, the large flock particles are allowed to settle out to the bottom of the clarifier. A ray continuously travels across the bottom of the clarifier and scraps the settled flock to the center of the unit. Pumps are used to pull the settled sludge out of the clarifier and send it to a sedimentation or disposal pond. The water that passes over the wire is collected and transferred to the filters. The reason clarifier occurs before filtration is so the majority of suspended particles can be removed prior to filtration, which avoids overloading the filtrations and thus allowing much more water to be filtered before the filters must be backwashed. Filtration. Clarified water enters the filters from the top. Gravity pulls the water down through the filters where it is collected in a drain system at the bottom of the unit. There are many different types of materials used in filters, the most common being sand and gravel. Many conventional plants are now using granular activated carbon as the media of choice because it is not only provided excellent mechanical filtration of particulate matter but also removes organic compounds which can cause taste and odor problems. Disinfection. Once the water has gone through the filtration process, it is about as clear and clean as it can get. However, there may still be bacteria and viruses remaining. To ensure these are destroyed, there must be a disinfection process employed. The most common disinfection process used in the United States is chlorination. Chlorine comes in many different forms including chlorine gas, chlorine dioxide, hypochlorite and others. Whichever method is used, chlorine is added to the water in an amount to ensure all microorganisms are destroyed. Water plants monitor the chlorine levels continuously and very carefully in the treatment water. They must add enough chlorine to ensure thorough disinfection of the water but avoids adding excess that can cause taste and odor problems when delivered to the customer. Storage. Once the disinfection process is completed, the water is stored. Storage usually takes place in an underground storage tank called a clear well and also is elevated storage tanks that are visible around town. There must always be an ample supply of water available in the event of emergencies. These can include power outages, fires, floods, etc. Distribution. So, how does the water come out of your kitchen tap? The stored water is pushed through underground pipelines all over town in what is called a distribution system. The distribution system consists of large water pumps at the treatment plant, overhead water storage tanks, large pipelines, smaller pipelines, fire hydrants, valves and water meters in your front yard. Thank you.